Hello everyone. In this lecture, we are going to study about logarithms. Logarithms is a part of mathematics and it is part of algebra. After the lecture, you will be able to solve the given simple problems using laws of logarithm. So before wasting any time, we will directly continue. So I would suggest please keep your pens and notebooks ready and note down the important points. So let's start. So before actually starting the logarithms, let's see its weightage in MSBT examination. Logarithm will be asked only for 2 marks. It will have only one question in question number 1A. That means the very first question of your question paper will be on logarithms. In this topic, we will learn laws of indices, we will learn logarithmic form, conversion from power to logarithmic form and vice versa, laws of logarithm, and then we will see the examples on logarithm. So as you can see, first we are going to learn laws of indices, power rules. Okay, indices is plural of index. So first of all, let's revise laws of indices. So here on your screen, you can see a power form. Here I have written a raised to n is equal to b. So here n, which is written above a, is called the power or index or exponent or degree. All these are common names. Out of these, the most common ones are power and index. So the one number which is written above a is called power, and this a is called base, which is written in red color. And then your answer of a raised to n is called basic number or numerical. So a raised to n is equal to b. B will be your answer. Now what does this a raised to n means? It means a is multiplied with itself n times. Then your answer will be b. If you multiply a into a into a n times, that means like this: a into a, and this number of a's will be n. You're multiplying a with a n times, so it will be called a raised to n. We will summarize this, we will shorten this, and we will write this a as a raised to n. And suppose your answer comes out to be b. So this is called the power form. So now let's see what are the laws of indices, laws of powers. This you have learned in your school. You have seen in your school, I think sixth or seventh standard. You first time you have come across the different rules of different laws of indices. So first, let's see examples. So if I write 2 raised to 3, then this number 3, which is written in blue color above 2, it is called power or index, and it tells how many times you have to multiply the base, right? And 2 is called the base, and 2 raised to 3 means what? 2 into 2 into 2, that is 2 will be multiplied with 2 3 times, and then your answer will come out to be 8. So 2 raised to 3 is 8. 2 raised to the power 3 is 8. Another example, you can see 4 raised to 3. Here I have written 4 as base, 3 is the power. That means 4 raised to 3 will be 4 into 4 into 4. Multiply 4 with itself 3 times. So your answer will be what? It will be 64. Correct. So answer is 64. Hence 4 cube is 64. Next, 6 cube. 6 cube is 6 into 6 into 6. Multiply 6 with itself 3 times. Your answer will be 216. Next, now let's see the laws of indices, the power rules. The first one is a raised to 0 is equal to 1. Means we will write it in words also. Means a is any number and the power is 0. So if the power is 0 for any base, then your answer will be 1. If you write 2 raised to 0, your answer will be 1, 3 raised to 0, 1, 5 raised to 0, 100 raised to 0, 1. Means as long as the power is 0, the base does not matter, your answer will be 1. So this is the first rule. Second, a raised to 1 is equal to a. Means if you have power 1 for any base, then your answer will be the same base. 2 raised to 1 is 2, 3 raised to 1 is 3, 4 raised to 1 is 4, and so on. So if the power is 1 for any base, then your answer will be the same base. Next, a raised to minus m. It is called the inverse property. A raised to minus m. If your power is negative, then you can make it positive by writing the reciprocal. So a raised to minus m will be 1 upon a raised to m, or vice versa. If you want to shift this denominator to the numerator, you can write a raised to minus m. Right? The power changes its sign when shifted from numerator to denominator and vice versa. If you are moving from numerator to denominator or from denominator to numerator, then only the sign of the power will change. Minus will become plus or plus will become minus. Next property, a raised to m raised to n. You have two powers, multiple powers. So what will happen? Base is only a, so base will remain the base and both the powers will get multiplied. Right? The powers to a common base get multiplied. A raised to m raised to n, it will be a raised to mn. The next very important property, this a raised to m into a raised to n. You have same base a and you're multiplying. Then what will happen? The powers will be added. Powers जो है वो add हो जाएगी. You will have a raised to m plus n. M and n both will get added. Right? We can write this in words as multiplication of the same bases implies addition of powers. Next, similarly, if you have division, instead of multiplication, you have division, then this plus on the right hand side will become minus. So a raised to m upon a raised to n will be a raised to m minus n. That means the division of the same base implies subtraction of powers. Remember, in the last two properties, that both the bases must be similar, a and a, right? So remember, multiplication becomes addition and division becomes subtraction. Remember this. Hmm? So these are the laws of indices, and using these we will derive or we will define the rules of logarithms. So let's see our definition of logarithm. So if y is equal to a raised to x, where a is any positive number, and remember a must not be 1, then x will be called, the power x will be called the logarithm of y to the base a, and it will be written as log y to the base a is equal to x. Log y to the base a is equal to x. So I will explain it once again. If you are given a raised to x is equal to y, or y is equal to a raised to x, so it will be called the power form. You can write it in logarithmic form as, you will write log of log, right? And what is the base in power form? The base in power form is a, so this a, it will come at the base of log, and we write the log base here, a, correct? We write the base of logarithm at the end of g, so here we will write the base a. Then what is the right hand side? The answer was y, so we will write y here along with log, and then the answer, the right hand side will be the power x. So this way you can convert the exponential form to log form or log form to exponential form. Remember this. Hmm? So this is the definition of log. So you can please remember this. So next, let's see examples. So y is equal to a raised to x, then you will write it as log y is equal to x, and base will be a. So just see how we are converting from exponential to logarithmic forms, right? The base is remaining base, but the base which was in power form is the base in logarithmic form. You can remember this. So this is called this is the pictorial representation of whatever I just explained in words. Hmm? So you can take screenshot of this. So next, now let's see example. If 9 is equal to 3 square, then this 2 will be called, the power 2 will be called the log of 9 to the base 3. Means for what power of 3 you will get 9? For which power of 3 your answer will be 9? That number will be 2. The power will be 2. Hence log 9 to the base 3 is equal to 2. So basically logarithm is finding the power if you know the base and the answer, right? So a few more examples you can see on your screen. If 8 is equal to 2 cube, then log of 8 to the base 2 will be 3. If 25 is equal to 5 square, then log 25 to the base 5 will be called 2, right? So once again I will repeat, logarithm and power forms both are equivalent to each other. Hmm? So these are few examples. So you can take screenshot of this also. So now we will see some more examples. Here a table is given. You need to complete this table using the rules which I just explained. Hmm? So 4 square is equal to 16. So how will you write it? You will write it as log 16 to the base 4 is equal to 2. You can say, take a log 16 to the base 4. Base will remain base, and we write base at the end of log. And your answer will be the power. The power will go on right hand side. And similarly, you can see the other examples, right? I have written for 5 examples here. So you can take screenshot of this. This is the relation. This is how we convert power forms into logarithmic form. And now we will do vice versa. Now we will be given some logarithmic form. We will write their power form. Correct? So now we are given log form. We need to write the power form. And now it is also very easy. What we will have to do, we will remove this log. This log will be removed, and this 2 will go to the right hand side and push 3 to the power. Means 2 will go to the right hand side and push 3 to the power. So you will get this 2 raised to 3, and only 8 will remain. Log is cancelled, 8 will remain. So your answer will be 2 raised to 3 is equal to 8. Same way, log 27 to the base 3 is equal to 3. So take this 3 on right hand side. So what will happen, this 3 will go to the power, and you will get 3 raised to 3, and your answer will be 27. And this is mathematically correct also. Correct? So right now we were given logarithmic forms, and we are writing their power forms. Right? So you can complete the rest of the examples. Okay? For your simplicity, I will show you the answers. The answers are, yes, you can see on your screen. 2 raised to 3 is equal to 8, 3 cube is equal to 27, and so on. Hmm? So you can take screenshot of this also. So till now we have learned how to convert the power form to logarithmic form and vice versa to convert logarithmic form to power forms. Now let's see types of logarithm. There are two types of logarithm. This is not important. It is only for your knowledge. There are two types of logarithms, common and natural. Common logs are the logs which are corresponding to the base 10, and the natural logs are the logs which are corresponding to the base e. The natural logarithms are denoted by ln. Hmm? This letter E is a pure constant, and it is a natural constant. Its details you will learn further ahead. Afterwards, you will come to know what does this E mean and what is this E. Hmm? So right now only remember the types of logarithms. The types are based on the base. So if the base is 10, then common logarithm. If the base is E, then natural logarithm. Hmm? Next. Now we will see laws of logarithm. First, number one, log 1 to the base a is equal to 0. This is derived from the laws of indices. Hmm. The first law of index was a raised to 0 is equal to 1. You might remember this. Just a few slides ago, I have explained this to you. A raised to 0 is 1. So convert this into log form. You will get log 1 to the base a is equal to 0. Hmm. So this is the logarithmic form. Hmm. First property of log. So remember the bracket, log 1 to any base is 0. Next, log a to the base a is equal to 1. Means if you are finding log of any number corresponding to the same number, then your answer will be 1. If these two numbers are same, then your answer will be 1. Okay, so log of any number to the same is 1. Hmm. Next, log of m raised to n is equal to n into log m. Means if you have power form inside log, you have a power form inside log, then what will happen? This power n will move ahead, and it will come in front of log and multiply. So log of m raised to n will be n into log m. Hmm? Base will remain the base. This is called the power rule, and you can do the converse also. If you are given this, you can take this power n inside and write as m raised to n. Hmm? So this is logarithmic form. Huh? So next, log of m into n is equal to log m plus log n, just like the multiplication and addition rule in indices. If you have multiplication of two numbers inside log and you want to separate the log, then you can separate the log, and this multiplication sign will become plus sign. So log m plus log n. This is very important law of logarithm, and we are going to use this in our examples also, in the questions also. So remember this fourth property. Property number 5, very similar. Multiplication will become division and plus will become minus. Hmm? So remember this, log of m by n is equal to log m minus log n. Property 4 and 5, these are identical to the laws of indices. Multiplication, addition, and division, subtraction properties. Hmm? Next, the change of base rule. Suppose you are given log m corresponding to the base n, but you don't want this base n. You want some other number to be the base. Then you can write this as log m upon log n and put the desired base. Whatever base you want. Suppose you are given log of 2 to the base 3. This is given to you, but you don't want base to be 3. Here base is 3. You want base to be 4. So you can do that. You can write that. You want base 4? Okay. Write this as log 2 upon log 2 upon log 3. Write this. Now base is missing. Put the desired base. What base you want? You want 4? Write 4 here. 4, 4. So it will become laws. It will become change of base rule. Hmm? This is not important. This property number 6 is not all that important for the exam point of view. And next, property number 7, if you have the reciprocal of any number and you want to remove this one upon m, then you can take this m to the numerator. The only thing will happen will be log will become negative. You will get minus log m. And if you want to remove this minus sign, this m will become reciprocal, one or the other. Hmm? So remember this. So this is the inverse. These are the 7 rules of logarithm. I would suggest to take the screenshot of this. And now we will see examples on this. We will see few examples on this. So let's see exercise. First example, simplify the using the laws of logarithm. You are given an example log 8 to the base 2. You need to find its value. You need to simplify this. You need to find what will be the value of this logarithm using the properties which we just saw. So let's see. Simply the solution. First, log of 8 to the base 2. Write 8 as 2 raised to 3. Now, why 2 raised to 3? Because here base is 2. So write 8 as I write 8 in power form such that the base is the given base. So we can write 8 as 2 raised to 3. Correct? So since 2 cube is 8. And next, take this 3 ahead. Take this 3 forward. This 3 will come forward using this property, the power rule, which we just saw. So 3 will come forward and multiply log. So therefore 3 into log 2 to the base 2. And log 2 to the base 2 is 1. Therefore 3 into 1 is equal to 3. Your answer. You can see here we have used two properties of log. This is one property, the power rule, and this is one property, which is the identity rule. So your answer will be log 8 to the base 2 is equal to 3. In fact, you can guess the answer. For what power of 2, your answer will be 3. For what power of 2, your answer will be 8. So you will tell 3. 2 cube is 8. Therefore, its answer is going to become 3. But we have to show it properly. So this is your final answer. Right? We will show one more example. Log 32 to the base 2 means you need to find the number you need to find for which power of 2 the answer will be 32. What will be the power of 2 to get 32? So your answer will be correct. For 5, 2 raised to 5 is 32. So its answer is going to come 5, but we will obtain it properly using the rules. So you can see the example is self-explanatory. 2 raised to 5 is 2, 5 is equal to 32. So take 5 ahead using laws of indices, and log 2 to the base 2 is 1. So 5 into 1, your answer is 5. Correct? So these are two examples. You can take screenshot of this and you can note them down in your notebooks. Now let's see one more example. Log 81 to the base 3. You need to find this. Now, we need to find the power of 3. So 81 can be written as 3 raised to 4. So we write 81 as 3 raised to 4 and then do the steps as we did in the previous example. So your answer will be 4. Log 81 to the base 3 is equal to 4. Same way you can see the fourth example, log of 125 to the base 5. For what power of 5 the answer will be 125? So your answer will be 3. You can see 5 cube is 25. 3 raised to 4 is 81. Hmm? So this way your answer completes. Take screenshot of this. Next. Now here we have two logarithms. Same method. Only one additional property will be used here, that is plus of logarithms. You have addition of two logs, so taking log common, the numbers will get multiplied. That means this property, the property which is written in the bracket, you can see we are using this. We are given the right hand side, we are writing the left hand side. Okay. So log m plus log n is equal to log m into n. So your answer will come out like this. You can see the example is self-explanatory. We have taken log common, so 4 and 8 will both get multiplied, so you will get 32, and this is nothing but our example number 4 which we just saw, and your answer will be 5. Hence log 4 plus log 8 corresponding to the base 2, the answer will be 5. One more example, or you can write, you have we have one more method here. What did we do? We first applied the property. You can do separately, calculate log 4 separately, log 8 separately, and then add the answers. So these are the two methods. Follow whichever method you find easier. Take the screenshot. Next, and now we will see some different examples. We'll see examples on finding the value of x. You will have an unknown in your equation. You need to find the value of that unknown. So log x plus 1 corresponding to the base 2 is 2. It is given. You need to find what will be this x. The method will be very simple. We will first convert this log into power form, into index form. And we have seen how to convert this. So write the given, we have written the given equation which is having x. So writing it, converting it into power form, we will have x plus 1 will be left, and this 2, the base 2 will go to the right hand side and push 2 to the power. So you will get log x plus 1 is equal to 2 square. Log will finish. So this is the conversion into power form. And now calculations. So x plus 1 is equal to 4. So x will be 4 minus 1, that is 3. So the value of x is equal to 3. That's it. This is our answer. Hmm? Now one more example. Suppose you need to find the value of x from this equation. Log x plus 4 to the base 3 is equal to 2. So convert it into power form. Power form convert. So this is the conversion into power form. X plus 4 is equal to 3 square. Base will remain base. The base in log is the base in power form. So 3 square. 3 square is 9. So you will get x is equal to 5. Right? So now for your simplicity, for your help, I have given you some homework for your practice. Please take the screenshot of these examples. The answers are also given, and solve them in your notebook. Hmm? So thank you very much. This was our logarithm. The main advantage or the main application of logarithm is to simplify the complicated calculations without using calculus. These logarithms are outdated now. These logarithms are hardly used in practical life because we are now well equipped with all the facilities, with all the applications, and with all the digital technologies and scientific calculators. So we can calculate whatever, we can calculate all types of difficult calculations on calci. Earlier, when calci was not there, 15 20 years earlier, when calculators were not there, so these calculations, the difficult calculations, were have to be done manually. So for manual calculation, the logarithm was very important, and it was used. So in today's era, the logarithm is very hardly used, but these concepts, the logarithm concepts, are very important, and they are going to help you in your high studies in the years to come. In your academic years to come, the logarithm properties are going to be used. Hence it is very important for all of us to learn this logarithm for the sake of our academic years going ahead, for your second year, third year, final year, etc. So thank you very much. This was logarithm. See you in the next lecture.